Hi, Eve. My name is Christopher Penn. I'm co-founder of Brain Trust Insights. We're a consulting shop that does a lot with machine learning, predictive analytics, things like that, and wanted to respond to your helper reporter inquiry, the 7 questions that you outlined. In terms of, at the bottom you had asked why we're qualified to share we build our own software, a lot of our own software. It's not for sale. We're not a vendor of software, but I've done a lot of work in this area to use this on behalf of clients. So let's dig into the questions. Number 1, what's the best way to begin building a predictive analytics strategy? Before you predict, the most important thing to do is to do driver analysis of your variables, of your predictors, because we have nearly unlimited amounts of data. So without doing that driver analysis to determine what variables to predict on, you'd just be picking things out of a hat. So there's 2 sets of variables that you would do driver analysis on. One are the business outcomes. So if you're in marketing and sales, for example, you would be doing lead generation or closed-won deals. If you're doing manufacturing, you'd be doing things like mean time between failure. And then you would take all of the diagnostic contributor variables that lead to that and run a prediction, run a driver analysis to say, okay, what variable or combinations of variables leads to this outcome or has a high correlation to the outcome. And then you do some A/B testing to identify, yes, this is a causative factor in the outcome, or this is just a correlative factor and there's no causative factor. That's how you start to build out what to predict on, and then you choose a methodology for running your predictions for what are you going to use for forecasting. The gold standard in statistics and machine learning is sort of the suite of ARIMA algorithms. That's autoregressive integrated moving averages. Most of them were invented somewhere between 1950 and 1970, but having them be available practically on something you could run on a laptop, for example, has only been in the last decade or so. Overall, though, at a big picture strategic level, it's why are you doing the prediction and what do you hope to predict? And answering those questions are important. And then you do the driver analysis, and then you do, after that, the the analysis and the forecasting based on the variables you isolate. Number 2, how can an organization ensure data quality for predictive analytics? That's a really, really good, really tough question. A lot of what you would have to do before predictive analytics for data quality purposes is EDA, exploratory data analysis. And that, you do exploratory and then you do comparative. EDA allows you to inspect the quality of your data sets up front, and there are a number of robust machine learning libraries and even just regular statistics libraries that do this really well, where you dive into your data sets, you understand, what are the variances, what are the medians, what are the anomalies. There are a number of good anomaly detection libraries that will help you isolate and identify what anomalies exist within your data that you would want to correct for, or tell you the data is no good. Once you've established the quality of the data that you do have, then you look for public or trusted third-party data sets to bind to it, to blend in, so that you build a robust data set from which to run prediction. For example, if you look in the Medicare hospital quality data set, about 30% of it's missing or damaged because hospitals underreport certain things. But if you blend in, we did this over the holidays, if you blend in census data and Bureau of Labor Statistics data, you can then build a machine learning algorithm to do imputation to fix the pieces that are broken. And that lets you get your data quality up to a high enough standard to then run prediction on. So ensuring data quality is a lot of EDA and then imputation and proven repair methods to repair a data set. Number 3, what are the dangers of having access to too much data? The number 1 danger is computation, time, and resources. When you're doing predictive analytics, particularly if you're doing stuff like multiple linear regression or you're doing stuff like random forests, the more dimensions your data has, the longer your compute time takes. So if you've got 5 dimensions, you could have 1 million, 1 billion, 1 trillion rows of data, and your compute time is going to be relatively low because you don't have to do that many variations of the data to get an outcome. Every dimension you add, every column, if you think of your data is a big spreadsheet, the number of rows is largely irrelevant. It's the number of columns that you keep adding on. The more columns you add, the more mix and matching you have to do, well, the software has to do in order to come up with a good prediction. So if you have 80 or 90 or 100 or 150 dimensions, you have a serious compute problem. You're going to be starting into compute problems that require like decades to solve. And so one of the things that you need to do as part of the preparatory process is to do things like dimensionality reduction. If you have too much data, even that becomes troublesome because you have to do multiple levels of dimension reduction just to be able to get to a data set that you can compute, or you're going to blow a ridiculous amount of money on compute time, cloud hosting compute time, just to get to a usable result. So that's one of the major dangers. The other thing that's a danger is computing variables that you don't necessarily want to have in your data set. So for example, let's talk about predictive in human resources. It's a very, very dangerous area because we can explicitly disallow certain criteria, say in the hiring process. You can say, I disallow age, I disallow gender, I disallow ethnicity. These are criteria that we may not make predictive judgments on hiring about. However, if we are ingesting data from the social graph, such as movies you like, music you like, books you like, certain combinations of those variables will create the same functional outcome as judging somebody on their race. And so we want to make sure that we're disallowing those results as well. When you have too much data, when you have more data than you can successfully manage, you risk creating those weak associations in the data. Number 4, how can an organization using predictive analytics respect data privacy and ownership? MVD, minimum viable data. What is the minimum amount of data that you need to do your job or to predict a successful outcome? And then don't collect the other stuff. So that goes back to the data quality question, exploratory data analysis, and then the algorithms you choose. Based on the data you have, what do you need to use in order to predict an outcome successfully? What statistically will lead to the target outcome? Everything that doesn't contribute to that, consider either not collecting or archiving or removing from your models, because all it's going to do is clog up your process time, and it risks issues with privacy and ownership. GDPR is the topic on everyone's mind because of the implementation deadline that just recently passed. So use predictive data on the data that you do have. Use publicly blended data sets in as well, stuff that does not have privacy implications. On the marketing front, one of the most important things you can do is focus on behavioral data rather than personally identifiable information. Do you care whether somebody is the CMO or an intern, as long as they follow the behaviors that lead to a conversion? Then probably you shouldn't, because the goal is to get the conversion to start the sales process. Just like, do you care whether someone is the right age for your product, as long as they're exhibiting buying behaviors? So that's the other area that certainly on the marketing side of things, data privacy and ownership, you don't need all that PII if you're doing a good job with behavioral data. Number 5, how can predictive analytics model complexity and usability be improved? A lot of the improvements that companies can reap comes on the preparation and analysis side. A lot of folks think you can just pour all the data into a big bin and have the machine do everything. And there's a little bit of truth in that, particularly when you get into deep learning, but that's kind of the lazy way of doing it. If you have great exploratory data analysis capabilities, if you have good ETL capabilities, then you will have fewer issues with complexity of models, complexity of predictive models. You will have lower compute times and things like that. The other aspect is interpretability, and this is a big problem right now in machine learning specifically and deep learning, is that we don't have as good a set of tools for interpreting the models as we do for creating them. The machines can do incredible jobs at creating great models, but they're largely black boxes. We don't know necessarily what's in the box. And so interpretability is sort of the next hot button in predictive analytics and machine learning in general, to make sure that we are able to explain how data is being used. And that goes back to question 4 as well. That interpretability of the model really matters. Number 6, what's the best way to keep a lid on predictive analytics costs? Remember that predictive analytics is rooted in data. The more data you have, the bigger processing time you're going to have, the more storage costs you're going to have, and frankly, the greater security risks you're going to have for things like breaches and stuff. The best way to keep a lid on predictive analytics costs is to keep and predict on the data you actually need and not on everything. You don't need everything. You need the stuff that's relevant. So having those abilities to refine your data, doing really good dimensionality reduction is important. It will help you contain resource costs, and not just financial costs, but also time costs. I was running a prediction the other day, and I had too many dimensions, and the process probably would have taken about 4.5 days to complete. For what was a relatively modest data set, but it just had too big a dimensionality. And so doing some dimensional reduction and things really helped to speed that up. Once I narrowed it down, I think it was like 90 dimensions, and brought it down to 6, it was done in like 5 minutes and stuff. So if I just sort of let the computer do its thing without any of the upfront work, the preparatory work, it would have cost a lot of time. Instead, by doing the prep work in advance and refining it and cleaning it up, I was able to get a result much faster. Number 7, do I have any other thoughts? The number one thing I think is a problem right now in predictive analytics is people do not understand predictive analytics. Fundamentally, it is statistics. At the end of the day, you are assessing the probability of certain outcomes, which means that people do not understand what predictive analytics cannot do. Predictive analytics cannot forecast things that have never happened. My friend and colleague Tom Webster over at Edison Research showcases a key example of this with the 2016 U.S. presidential election. Those two candidates had never run before together in that kind of situation, and there were a whole bunch of predictive models that different journalists and publications put together trying to predict the outcome, but they were using 2012 data sets, 2 different candidates, 2 very different voter bases, and so they were trying to forecast based on a bad model, right? So that particular event had never happened before, and so you can't forecast on that. And the second thing is, if your data is not predictable in the sense that it has regularity and seasonality and cyclicality, predictive analytics will not work. For example, there has been, of course, an enormous amount of time and money invested in trying to predict the stock market. The stock market is not a rational and predictable entity. It is a massively complex system with hundreds of shadow inputs, things that you don't have access to, you don't have data for, and so you can't predict from. And so you can't predict things that have never happened. You can't predict things that are unpredictable. But there are a lot of people who believe that predictive analytics can be used to forecast anything. If that were actually the case, we could forecast disasters far in advance. We could forecast elections far in advance. And we would have far more certainty in all of our systems. We will not likely get there within our natural lifetimes. Maybe a sentient AI 50 or 100 years from now will be able to do that, but that is beyond our capabilities right now. And one of the biggest dangers for business leaders, for IT leaders, for marketing leaders is these mistaken beliefs that you can forecast anything. You can only forecast things that are predictable. And so be aware of that as you engage on and you embark on your predictive analytics journey, that you need to predict the things that are predictable, and don't try and predict things that are simply out of forecastable range. My name, Christopher Penn. Title, co-founder. Full name of the organization is Brain Trust Insights. All this will be in the email. Thanks for watching. I've included an AI transcript, but again, as with all forms of machine learning and AI, it's not perfect. So I include the video for your reference as well. Thanks for watching. I'll talk to you soon.